Okay, so today we're going to start talking about surface area. Now, surface area has to do with three-dimensional figures. If you had to guess what surface area meant, what would you think it was? That's right, it's the area of a surface. Okay, so surfaces, think three-dimensional, and surface area means to find the area of the space on the outside of the figure, the two-dimensional space, like area. Okay, and to do that, what we're really going to do is we're going to take these three-dimensional objects and lay them out flat, which should ring a bell for you. The lesson we just finished was on nets, which means that you're taking that three-dimensional figure and drawing sort of a two-dimensional representation. If you took a three-dimensional figure and laid it out flat and found the area of what it looked like flat, that would give you the surface area. So let's give a more formal definition for surface area. Surface area is the combined area of all of the faces. So if I hold up one of these pyramids, the faces are all of these triangles, and then the shape on the bottom is the base. So if I were to find the area of all of those shapes individually, that's the surface area. Okay? And so really, it's taking area of shapes that you already know how to find the area of. You know how to do area of a triangle. You know how to do area of a square. And adding those areas together. When you think surface area, I want you to think about wrapping a present. Okay? This is what surface area is all about, is covering the outsides of a figure. All right? So if I were to wrap a present, I would have to figure out how much paper would it take to cover the outside of this box. That's surface area, okay? Not to be confused with volume, which we'll be talking about later. And just to illustrate what I was speaking about earlier, here you've got a box, a three-dimensional box, and this is what the box would look like if it were laid out flat. Now, if I laid that out flat, I've got a bunch of rectangles here, and you already know how to find area of rectangles. So to do this, I would just find the area of each rectangle and add them all together. Okay, I need the area of this, and that would give me the combined area of all of the parts of this box. One more. Lateral area is very similar to surface area. It's the combined area of the lateral faces. And remember that lateral faces, if you remember back when we talked about solids, lateral means not including the bases. Okay? So if I was looking at a prism, it would be all of the rectangles around the sides, but it would not include the top and the bottom. That's lateral area. So the difference between lateral area and surface area is in lateral area you do not count the base or the bases. All right, so let's look at this first example. A cardboard box has a base 7 inches by 12 inches and a height of 17 inches. I want the total surface area of the box. Well, I'm not going to get anywhere without drawing a picture of this thing, so let's draw it. Here's my box. Okay. And the base of the box is 7 inches by 12 inches. So that means this here is 7 inches, this is 12 inches. So the bottom of the box is 7 by 12. And then the height of the box is 17 inches. And I want the total surface area of the box. So a box has 6 faces. It has a front, has a back, has a top and a bottom, has a left and a right. And and those are all rectangles. So I'm going to find the area of all of those rectangles individually. And I'm going to sort it out like this. Here's, whoops, front, back, top, bottom, left, and right. Now you're going to get more efficient at this, and we're going to talk about some shortcuts. But for now, this is the most simple way to go about this. It's also a way that will always work. So we're going to talk about some formulas, some tricks, some shortcuts. But if you forget any of those things, come back to this. I just need to find the area of all of the pieces of this box. So if I want the front of the box, that's this here. Think about which two numbers you need to find the area of that blue rectangle. It would be 7 inches on the bottom and 17 inches up the side. So 7 times 17 gives me, let's see, that's 70 and 49, so 119. And the back is going to be exactly the same as the front. If this is a standard cardboard box, the front and the back are going to match. So the back would also be 119. Let's save ourselves some work here. Now let's look at the top. The top is here. So if you look at that rectangle I'm outlining in red, the dimensions of that are 7 along the side and 12 along the depth. So this is 7 times 12 for the top, which is 84, which means the back is also 84. Okay? I'm sorry, that was bottom, not back. I just called that the back. The bottom would also be 84. The top and the bottom match each other. Sorry, I forgot I had 2 B's in there. So all that's left are the 2 sides of the box, the left and the right. So the left is over here. Hopefully you can see that over all my scribbles. There's the left side of my box. And my dimensions there are going to be 12 inches for the depth and 17 inches for the height. So 12 times 17 is 204, which means the right side of my box is also 204. So then for my total surface area, I'm going to take all of those numbers I just worked so hard to get and add them up. I'm going to do 119 plus 119 plus 84 plus 84 plus 204 plus 204, and that gives me a grand total of 814. Now I've specifically avoided putting a unit on these yet because I wanted to discuss what the unit should be. These are 3-dimensional figures, but remember all of these are really just areas. Think about how we measure area. We measure area in square units, square inches, square yards, square centimeters. So surface area is just a type of area, which means that the unit is in square units. So it would be 814 square inches for your surface area. Let's just refresh our memories here. The difference between lateral area and surface area. What is the difference?
Lateral is not including the bases.
Okay.
Surface is including the bases.
Good. So lateral area is just talking about around the outsides. It's talking about this, and if I could wrap around the back, I would, but it is not including the top or the bottom. Okay? So lateral area is just around the edges, but does not include top and bottom. So if I wanted to find lateral area of this, if I were to take this can apart and lay it out flat like a net, what shape would that lateral area be?
Rectangle.
It would be a rectangle. Picture it like a label on that can. Okay, if I were to take that label off and lay it out flat, it would be a rectangle. Okay, so I'm going to draw myself a rectangle.
Would it be 8 inches?
Not quite. Good guess. Well, what's the height of that rectangle? That's easy, right?
Do we have to like figure out the
6.
circumference?
Yes. Okay, this right here is going to match with this. Okay, the height of the can is going to be the height of the rectangle. So this is going to be 6 inches. Now this, hold on just a minute, stop guessing for a minute. This is what's going to wrap around here. Do you agree with that? That if I took that apart, it would form this circumference?
Oh, yeah.
Okay, so this measurement is equal to the circumference of the circle. Now, how do you find circumference? Okay, so it would be, well, not quite. It's 2 times pi times radius. Is the 4 the radius?
Oh, 2 times 2 times 4.
Okay, so the radius would be 2 inches, is what I think Kyle is trying to say. So this would be 2 inches. So I would do 2 times pi times the radius, which is also 2. Which, remember, I could also just do pi times diameter. So I could do pi times 4. Because 2 times that 2 would give me back my diameter. And let's see, this is going to be 4 times 3.14. Can someone help me out with that? It's going to be 13 something. 12. 4 times 3.14. 12.56. Maybe? Am I right? Okay. So 12.56 is the length of my rectangle. So that's this. So now what do I do to get area? Okay, now it's just a rectangle, so I'm just going to do length times width, or base times height. So I'm going to do 12.56 times 6. I'm going to need that number again. 75 point, thank you. And how do we label surface area again? Okay, yeah, surface area is just a type of area. So we're still labeling it in square units. So this is in square inches. Okay, so that's your lateral area. Do I have to start from scratch to find surface area?
No.
No, because surface area would just be everything, including the top and the bottom. So if I already have the space around the outside, the only thing I need to add is what?
The area of the circle on the top.
The area of the circle on the top and the bottom. But they're the same, right? Do you agree that if this is a cylinder? Yeah. So what I would do is I would just find the area of the circle.
It's not truncated.
No, it's not truncated at all. Area of a circle, what's your formula for that?
Radius times
Isn't it?
pi squared.
Okay, close. Pi times radius squared. Okay, pi times radius squared. So in this case, that would be
4 times 3.5.
pi times 2 squared, which is also, that is just kind of a coincidence, happens with that 4. So 12.56 is the area of one of the circles, but I need 2 of them, right? I need 2 circles. So I'm going to take that 12.56 and double it because I need 2 circles. And then I also want to add that to the lateral area because surface area has to include everything. So I'm going to take that and add it to the number we already found up above for the lateral area. 75.36. And I'll wait for your help with that one. It's going to be around 100, but
100.48.
nice.
Good job, Nick.
100.48 square inches. Questions on that at all? Okay. Think you could do that on your own?
What kind of plus sign is it?
A badly written one.
Dude, that's clearly an F.
Example 3. 75 square feet of wrapping paper is needed to wrap this box. So we're pretending our wrapping paper does not overlap, that we are wrapping it perfectly.
That's
Okay?
not very good, right?
The height of this box is 12 inches and the width is 9 inches, and I need to know the depth if my total surface area is, what is that number in front? I can't read it. Can someone read me that number? How many square feet?
6.75.
6.75, thank you. Just write that there for myself. Okay. We do have to convert to feet. I'm glad you caught that. Yeah. And that's what I would do. I would not try to convert any sort of unit that is a square unit because it doesn't convert like other units do. It's possible to do it, but you can't just take that and divide by 12, or I'm sorry, multiply by 12 to get it into inches. It's easier to multiply or to divide just regular inches and turn them into feet. So that is the first thing I'm going to do. Is I'm going to take that 12 inches and I'm going to convert it into feet. Divide by how many? How many inches in a foot? 12. So one of the dimensions, this is really just 1 foot. And then 9 divided by 12, I believe, is 0.75. Okay. So the height of my box is 1 foot. I'm going to go ahead and label that. Okay, no. And the, oh yes, 9 divided by 12. And the width of the box is 0.75 feet. And I am looking for the depth. So I'm looking for this. I'm going to mark what I'm looking for with an X. Bryce.
Is the, oh, never mind. I was looking at it different.
Okay.
How
Okay.
you can do it.
What can you do?
'Cause,
Got it.
No?
Scared me.
Bryce?
Can I say what X is?
If you think you know it.
4 inches.
Mm,
No.
I
Wait.
don't know. It might be. I would have to work it out. I know I worked it out when we first did these, but. Okay, here's what we're going to have to do. Okay, guys. Come on. I'm going to shrink this up a little bit, give myself some more space here. How did we find, if you look back at example 1, if you look back at example 1, how did we find the surface area of a box? Nope.
No.
Of the whole box. Look back at example
On
1.
both bases.
Nope.
Front, top, bottom, left.
There you go. We found all the pieces, right?
Oh, yeah.
We did front, back, top, bottom, left, right. That's what we're going to do here too. Okay? And we're just going to use an X where we need to. So I'm going to do front, back, top, bottom, left, and right. Okay? So the front of this box is here. So what do I multiply for that?
0.75 times 1.
0.75 times 1. Good.
Is that 0.75?
Yep. So that equals 0.75. So what does that mean the back is going to be?
0.75?
Mm-hmm. Remember, the front and the back are always going to match. Now,
We got.
top. Did I lose you, Isaiah?
Why are we multiplying by 1? It's the height.
Because this box, or this square right here, the dimensions of it are 1 foot and 0.75 feet. So if you're finding the area of a rectangle,
Oh.
okay? So I did the front and the back so
Alright.
far. Now I'm going on to the top.
You're a
Which
good
is-
tracer.
Oh, thanks.
Better than I do.
Okay? What am I multiplying there? For the top.
0.75 and X.
0.75 times x, yeah. And that I'm just going to have to leave as 0.75x for now.
Same with the bottom.
Same with the bottom.
Same with the left and the right.
Not quite.
It's 0.1.
You guys think about the left and the right for a minute.
Is it 1X?
It's 1 times 1x, right?
What? Yes, 1X.
It's true now.
Just 1X.
The media center. Okay, yep. Okay. So what do we decide for left and right?
I said 1X.
Okay. Let me trace that for those of you who maybe aren't seeing that. I'll do it with the blue. So on the left over here, oh, now I'm a really good tracer.
Look at this.
Okay.
That's like part of a triangle.
These here, this would be 1 and this would be x. So this would be 1 times x and 1 times x.
Whoa.
So now that I have all of those, what am I going to do with that? There's a piece of information in this problem we haven't done anything with. Nick?
You like combine them all and equal to the 6.75?
Yeah, that's exactly right. I know that my total surface area needs to be that 6.75. So I'm going to add 0.75. I know. Plus 0.75 plus 0.75x. Okay, Bryce. 1 echo's bad enough. Plus 1x plus 1x. And I know it has to equal, oh boy. $6.75. Okay? And now I'm going to solve it. These two are just numbers, so I can combine those to make 1.5. And all of these are x's, so I can combine all those. How many x's does that give me total? I have 1.5 here and then a 1 and a 1, so I believe it's 3.5. 0.75 plus 0.75 plus 1 plus 1. So that would be 3.5x.
Then we'll do minus 1.5.
Mm-hmm.
6.75.
That's it. So now I'm going to subtract the 1.5. Make this 3.5x equals 5.25. And then divide by the 3.5. Need your help with that one. 1.5. So that's 1.5 feet. If I wanted to turn that back into inches, what would I do with it? Okay, I would multiply it by 12. So 1.5 times 12 would give you 18. Because that's 1.5 feet. That one was a tough one. Were you able to at least follow it okay?
No. Yes.
No, where'd I lose you, Isaiah?
I don't know. I just don't understand why the 1x or the 1x and the 7 or 0.75 after there.
Okay. I didn't know one of my dimensions. I didn't know one of the parts of the box. Let me pull this back down. So I called this side over here x.
Yeah.
Okay?
Okay.
So like when I went to do this top part, this was x and this was 0.75. So if I wanted to find the area of that, I would do 0.75 times x, which is where this came from. Okay? And if I wanted to do that blue side, this was x and this was 1. So to get the area, I would do x times 1, which is 1x. Okay? And then I said I knew that my total surface area had to be this, so I added all of those up and set it equal to that 6.75, and then solved. Some of these problems get pretty in-depth. That's why we're kind of taking it slow with this stuff. Questions on that at all? Okay, find the surface area of the right triangular prism below. Okay, I'm going to show you, actually we're going to do this one way, and then I think after I hand your test back, I want to come back to this example and talk about it in a different way. Okay, but we'll do this one together now. Okay, what I would do with this one is it's not going to be quite as black and white as the boxes, like the front, back, left, right, top, bottom, but you can just find the area of the faces and add them together. So you've got a triangle, right? And then you've got 3 different rectangles. Do you see where I'm getting the 3 rectangles from? I've got a triangle in front, a triangle in back, and then I've got a rectangle here, I've got a rectangle on the bottom, and then I've got this slanted rectangle here. So those are the pieces that I need to find the area of. Okay? Let me see. Okay. So I've got, I've got a triangle that I'm going to end up multiplying by 2. Why am I multiplying the triangle by 2? Because I've got 2 of them, right? A front and a back. And then I've got the rectangle on the left. I've got a rectangle on the bottom. And I'm just kind of using my own notation here, just kind of making it up as I go.
See, you didn't actually look at it.
Wait, which one is
Okay.
what? Because there's a back and then there's a base.
I'm calling this the bottom. The front and the back are the 2
I know
triangles.
those both start with B.
You're right, but I didn't do one for the back because I just called it the triangle. You can do this in whatever way makes sense to you to sort this out is fine. I wanted you to see that I had 2 triangles that were the same and then 3 different rectangles. Okay, so if my kind of classifying of them is confusing.
Is the left one, is with the L, is that the 16 times 10 that you would do?
Yes. Let's start with the triangles. How do you find area of a triangle?
Height times.
Okay, 1/2 times base times height. And if this is my triangle, I want to do 1/2 times what times what? Okay, so if that's my triangle, I'm going to do 1/2 times 12 times 16. And then I'm going to multiply that by 2 because I have 2 of those triangles. Does that make sense that I'm taking care of this triangle and this triangle in the back all in one shot? Because they're the same. It's a prism. Let's see, 12 times 16, I don't remember. 192 maybe? Okay, and then really multiplying by half and multiplying by 2, that's just going to be a wash. But if you don't believe me, go ahead and multiply out 1/2 times 12 times 16 times 2. But it should come out to be 192. Mm-hmm. All right, now I'm going to look at the rectangle on the left, which is this rectangle here. Want to see which rectangle I'm talking about? What's the length of this side? That's 16. What's the length of this side? 10. Yep, that matches with this one, so that's 10. So 16 times 10 is 160. Okay. And then, let me grab a different color. The bottom rectangle would be here. So what 2 numbers am I using for that one? 10 and 12. Yep. So 10 times 12 is 120. Okay. And then the slanted rectangle, or the top rectangle, would be this. What 2 numbers do I need for that? 10 and 20.
What is it?
10 times 20, 200.
Oh.
And then let's add my surfaces together. So I'm going to add 192 plus 160 plus 120 plus 200. 280, 480, 580. I think I got 572. But I did that in my head, so please somebody check me.
I got 672.
You did get 672?
6.
Oh, you're right.
Oh, Mr. You bad.
Yeah, it
I
happens.
did differently. I did the 96 plus the 96.
Oh, that's fine.
Both sides. But I got 564.
What?
564. You're missing something. I forget what. But. Okay.
Oh, I did plus 12, not plus 1.
Oh, yep, that'll do it.
I'm the dumb one.
How'd you feel about that? I want to show you a different way to think about that one. Okay, and this kind of leads into what your book gives you as a formula for this. Remember I told you that I don't really believe in using the formulas for these because you have to use kind of a different formula for every one. But there is sort of a generalized formula. So you can write this down. If you've got some blank space on the back, I think there's a blank square on the back of this. Or maybe the back page is blank. I don't remember what I left you with. But you may want some space for this. I want you to think about that prism that we just talked about. Okay? In fact, I wish I had a way to have that picture up here. That's okay. That prism that we just talked about, maybe I'll just redraw it, because I know how you love my artwork.
Oh, yeah. You're like Van Gogh.
Oh, yeah.
Good drawing. Good drawing. Good drawing.
Do it again.
But,
Okay?
no.
Guys, not right now, please. And help me out with these numbers. I believe this was 10 down here.
Yes, and then the one on the left was 16.
This
And
was
then
16.
the thing.
Oh, wait, maybe this one was 10.
10 is 12.
This is 10 over here, right?
Wait, so
And
10
it's
is
supposed to be 12.
and 12 is
Thank you.
10. Wait, no, it's not.
I've got you for-
And then 20's back here. Okay. If I were to take this apart as a net, okay, I would have some rectangles, right? I would have, let's see, well, they're going to be kind of like this. And then, let's see, these would be my right triangles here.
Are we drawing this or are you?
That's not a right triangle.
It's up to you.
Oh.
If you want to draw it, you can. Okay. So if I were to cut this back, or if I were to fold this back up, I would fold those two triangles down and then the rectangles around it to make that prism.
That is not right.
Yeah, that's not right.
The top one is not right.
Dude, just go with it.
Oh, are you just questioning my drawing?
No, the top one is not right.
You're not right.
I don't
It's
think
not
the
a
triangles
right
are
triangle.
right.
It's as right as it's going to get. I marked it right, so you have to believe me.
No, but like the thing when you fold it up,
Mhm.
it won't make that shape though.
Why not?
Because it folds up like this.
This rectangle is this,
Yes.
okay? This rectangle is back here, and this rectangle is on the bottom,
That was the most confusing
okay?
drawing.
Doesn't take a
Well, then
right
wouldn't the one on the far left side wouldn't it have to be longer than the rest?
Possibly. I'm just going to put the numbers in, and you're going to believe me. That's how it's going to work.
I was
Okay.
thinking that like the
But-
right triangle part would go next, like right on the
Now, it could. You could draw it that way. These triangles could go anywhere on any one of the three rectangles. It wouldn't matter where they went. Okay? Wouldn't matter at all. Let me put in the lengths of that triangle. Maybe that'll help a little bit. So this is the hypotenuse. So this is going to be 20 down here, right? And then this is going to be the 16, and this is going to be the 12.
Is there such thing as
Okay.
an equilateral right triangle?
What do you think?
Yeah.
Yeah, probably.
What do all the angles in an equilateral triangle have to be?
Huh?
What do all the angles in an equilateral triangle have to be?
equal.
Well, they have to be equal, and they all have to equal what? 60. So can you have a right triangle?
No.
No, because all the equal. You can. Yeah. Okay, so now picture folding this up. If this side length is 12, what's this side length? 12. Okay. Which means this down here is also 12, right?
Oh, yeah.
What's this one?
16.
This is 16 to match with this one, right? 16.
We can't see where you're pointing, so.
Oh, you're right.
We're just guessing.
Well, it was the last one on there.
Okay.
Okay. And let's see. This is going to be.
All those lines in the middle are 10.
Yeah, that's what I was just getting to. These would all have to be this, right? Because that's the height of all of those rectangles, are these. So this would have to be 10. So now, what if, and I don't know if this will let me do it. It will not. What if I got rid of these lines? Wouldn't I just have one big rectangle? Can you see that? That would just be one big rectangle. So I could find the area of just that rectangle. What would I need to find the area of that rectangle?
10, and then you need the 12 plus 1.
Okay,
plus 6.
so this length right here would just be these three things added together, right? I don't need the actual number, but I just need you to see what I'm talking about. That this length up on top would really just be these three numbers added together. Well, where did those three numbers come from?
The triangle.
Okay, it was the side lengths of the triangle, right? What is it called when you add up the sides of something? Perimeter, right? So doesn't this 16, 20, and 12, isn't that just equal to the perimeter of the base? Okay? That those three numbers added together, guys, those three numbers added together just equal the perimeter of that triangle? Okay, just a minute. And then this is the what of this prism. And this one's kind of hard to envision because this one's kind of turned on its side. Remember, a prism, the bases are the two shapes that match. So if you were to picture this prism kind of turned over so this triangle was on the bottom, that 10 would be the what?
10 would be the height.
The height of the prism, right? So this 10 is the height. Okay? So if you wanted to find the area of this whole rectangle, you would just do the perimeter of the base times the height of the prism. That makes sense?
Yeah.
Okay? So I could say that surface area is the perimeter of the base times the height of the prism. And then what pieces am I missing? If I just, all I've done so far is this big rectangle. The two triangles, which are called the what?
Bases.
The bases. And they're exactly the same, right?
Yeah.
So if I found the area of 1, I could just double it.
Yeah.
So then I could do 2 times the area of the base.
That's like more work though.
Not necessarily. Not necessarily. And again, this is just, I'm kind of showing you more than one way to think about it so that you can latch on to whichever one makes more sense to you. Okay? Because you're going to get to some shapes that are like think about a hexagonal prism. You're going to have 6 different rectangles around the outside, right? You could find the area of each one individually. That will always work for you, and that's why I showed you that way first. Or if you had a way to find the perimeter of that hexagon, you could just do that whole perimeter times the height, and that would cover all of your rectangles. Okay? Does that make sense?
But, like, if you found like one height or one triangle, then you could find the rest. You could just find the hexagon.
If it was a regular hexagon, yes. Okay, if all the side lengths of the hexagon were the same, then yes. Okay? So this was just another way to think about it. This is the way you're going to see in your book a lot, and they will make references to this whole perimeter of the base thing and height of the prism. So that's why I wanted you to see this. It doesn't mean that you have to use this, but I wanted you to kind of see the difference, the relationship between these things. Okay? That really, when you're working with a prism, you can think of it as one big rectangle that just has side lengths that are a perimeter and a height. Okay? Yep.
We're in your test.
Yeah, those.
Yeah, well, I went over that one instead of going back to the one on your test, but when you look at your test, I think we're going to make reference to that again. Okay, a marketing agent is creating a new label design for Campbell's Soup. A standard can is 4.5 inches tall and 3 inches in diameter. How many square inches does the designer have to create his image? Well, if he's talking about a label, what shape is he talking about? The rectangle that's really just the what of this can? The lateral area. Okay, so what I'm really trying to find is the lateral area again.
Can I see the danger?
Okay, no. Let me put these numbers in here. So the can is 4.5 inches tall. And the diameter, which is the entire way across, is 3 inches. Okay? So my label is going to look like this. It's going to be a rectangle. What's the height of my rectangle? 4.5. What's the length at the top?
3 pi.
Okay, it's the circumference of the circle. So the circumference, just a minute, is 2 times pi times radius, which is 2 times pi times what? 1.5. You could also do pi times diameter, which would have just been pi times 3. And I think that comes out to be, let's see, 3 times pi is going to be 9 point something. 9.1 maybe. 9.2. There should be people other than Nick typing these numbers in. Darnell, will you pick your head up for me, please?
9.4.
9.4. Okay. So now what am I going to multiply together to get the area of this label?
4.2.
I'm going to do 9.4 times
4.5.
4.5.
42.2.
What is it?
42.3.
So this designer has 42.3 square inches. Okay, just a second. Okay, so that was just, there was really nothing tricky about that problem other than figuring out what part of the can you were trying to find. Okay, once you knew you were finding the lateral area, you should be good. Just to drive home that point again, so if I took this apart and made it a net, okay, you told me that this would just be the height of the prism, or the height of the cylinder, right? Stop tapping. Thank you. This would be the height of the cylinder. This would be the what? The circumference, but isn't circumference just a fancy name for,
Around the outside.
which is a fancy word for perimeter, right? So that's exactly what you just did. A second ago, when you found that lateral area, you said that it would be the circumference times the height, which is a fancy name for perimeter times the height. Okay, which is what I was showing you when I was showing you about how to unwrap that triangular prism. It's just the perimeter of the base times the height. If you wanted the entire surface area, then you would add on 2 times the area of the circle. But in that last problem, you didn't need this piece of it. Does that make sense, Travis?
We go back to the problem.
Sure.
Finish first.